So when we look at the complex plane, which is just an ordinary Cartesian plane, but instead of the x-axis and the y-axis, we have the real axis and the imaginary axis. All right? So if I wanted to graph, for example, 2 plus 3i, it would be right there. And one very interesting thing that jumps out at us immediately when we look at this is that the modulus of a complex number is associated with the distance from that complex number to the origin. All right? That can also be extended to say, if I look at let's say this is 5 plus I, what do you suppose the modulus of 5 plus I minus 2 plus 3I represents? So this is going to be 3 minus 2I, right? Because I go 3 over and 2 down. All right? This gives square root of 13, making this an isosceles triangle and immediately opening up all kinds of manipulations from geometry to complex numbers. Okay? But this also allows us to interpret z1 minus z2 as the distance from z1 to z2 in the complex plane. All right, and maybe it's better for me to write this as z2 to z1. It doesn't matter, but I'm saying because z1 minus z2, just like 5 minus I, or 5 plus I, minus 2 plus 3i, gives me a complex number that goes from 2 plus 3i to 5 plus I, 3 minus 2i. All right? So that allows us to interpret certain equations in the complex plane. So for example, that equation, the solutions to that equation represent all of the points z in the complex plane that are 3 units away from I. Okay? So this would give a circle of radius 3 centered at I. All right, so just something very simple like that will give us the equation of a circle in the complex plane.